Good afternoon. I'd like to demonstrate the power of top-down design using SolidWorks derived sketches. I was first introduced to the power of derived sketches in SolidWorks by Stephen Wiles. He was a mechanical engineer who was working for ZAG Incorporated at the time. He was a very talented engineer who was always willing to share his knowledge with other engineers and designers at ZAG. I've created this toolbox assembly made up of the base and the lid and an internal tray. And of course the handle and these covers. To help illustrate the power of derived sketches, I've assigned a number of the dimensions to variables in the equation list. Those variables are also linked to an external text file, so I can control those dimensions from outside SolidWorks, such as Visual Basic Program. That file could also be written to by Excel or even Notepad. That control file is right there. If I edit it and look at the equations list, here's the variables that are being overwritten or assigned to by this text file. The control part is the first part in the assembly. This part has the linked external text file of all the variables. When that file is changed, the variables update to the new values. And those variables in turn are linked to the dimensions in the sketches of the control file. So if I looked at that file, it's a bunch of sketches and planes, and they are controlled by those variables. So I have this Visual Basic program here. If I change these dimensions to new values and update the file, it should then update my toolbox to those new values. And if I have a robust model, then I shouldn't get any errors here or failed features in my feature tree. So it looks like it updated well. The hinges in the back and the latches in the front, and I've got a good part there fitting there. So let me demonstrate how to create this kind of model. Maybe something a little simpler, not quite as involved. We'll start with maybe a cabinet, a 4-drawer cabinet, I think will be an easy way to demonstrate the power of derived sketches, which I also used in that toolbox. Again, I have a control part that if we edit it, it's got these individual sketches, and if I turn on my annotations here, let's view our annotations. So that file is the control file. It's got the plane that defines the back of this cabinet, and the base cabinet itself is controlled by just a rectangle that's again controlled by those variables. And let's try, in this case, I've got a macro created. Let's see if this will update correctly. Run this macro. It's a VB macro, so I can create this by saying, let's put some dimensions in here for the height, the width, we'll say is 64. The depth, we'll say is only 24. Cabinet top space, we'll say is 2.5. The bottom is 3.5. Cabinet side space, 1 inch. Case between the drawers, we'll say is 1.5. The space between the spaces, the faces of the drawer, this little space here, we just say is 0.75. And then the relative height of the third drawer to the others, we'll just say is 1 to 1. And we'll exit that and update our drawers and my cabinet, and it updates. So we can turn off those. So let's try something really basic here. If I start with just that control file, let's pull up a copy of that control file. And I've created a copy but eliminated a couple of things. Let's finish controlling this bottom drawer here. In other words, if we place a dimension on here, and rather than having that as a driving dimension by explicit input, I can control it by a variable, of course, assigning that dimension to a variable. And let's see, bottom space right there. So now that dimension from the bottom of the cabinet to the clearance, or for the bottom face drawer, it would be controlled by that variable. Let's also control the back plane. See, it's this explicit dimension here. Double click on that and say equals to a global variable, and it's equal to the depth. It brings that in at 24. So add the additional dimensions on there. Notice that you can turn those on the annotations. You can right click and turn those annotations off and on. And if we now create an assembly and insert that as our very first part in the assembly. So, and also then I now insert the parts that I want to use this sketch or these sketches to create the cabinet and drawer. So I'm going to create 5 new parts. I'm going to create the outside cabinet itself. So I file, save, and this is going to be the cabinet base. And we'll save the first drawer, save as a copy and open. I didn't need to put that part 1 on there. So drawer, we'll call it the top drawer. File, save as, copy and open, create drawer 2. Let's see, just say drawer 2. Save as a copy and open, drawer 3. Save as a copy and open, drawer 4. Now let's insert each of those parts into our assembly. We'll say, go to assembly, insert the base, insert our top drawer, insert our second drawer, insert our third drawer, and insert our fourth drawer. Let's save this off, our assembly. And let's create the base cabinet. So now to use a derived sketch, I edit the cabinet and then expand my control file and grab the base cabinet control, which is just that rectangular shape there. Select that sketch, and then also select the front plane, or the plane that I want to derive this sketch to. And then I can use the derive command, insert derive sketch, and I'll locate this, snap it to the origin, and orient it, snap it up to that corner so it turns black, meaning it's completely constrained. And now I can use that sketch to extrude it. And let's turn on our planes here. And I'll extrude it up to surface. And let's edit, keep that base cabinet edited, and we'll select the front, expand my control file, go to the top drawer control, and insert, derive sketch, locate this, and orient it, and extrude it. There's a cut. Let's before we do that, let's shell this. Let's shell this base right here. So let's go back in time here. Just let's end that sketch. Let's go back in time just one step here. Let's shell this cabinet. Say it's 5 millimeters. We'll change the units on that too. Let's put it in inches. So that shell, let's shell it to maybe 1/2 inch. Use 1/2 inch panels on there. And then we'll go forward again to that sketch. Now let's cut that hole out for our first drawer. So we'll extrude cut and just do it up to next. Let's cut the second hole on the front plane. Grab the second drawer, insert, derive sketch, locate it, and orient it. It turns black, meaning it's fully constrained. I can then extrude cut that one up to next, and so on. I can keep doing that with the others, but let's just create the first drawer. So I'm going to stop editing the cabinet, and let's edit the first drawer. So again, I'll look, here's the top drawer. We'll edit that. It's just an empty file. Expand it. We'll go to the front plane, expand my control file, go to the first drawer, the top drawer, and say insert, derive sketch, locate it and orient it. And rather than using that directly, let's offset that because we've cut with that same profile. Let's use that sketch to just do an offset, so we've got a little bit of a clearance there. So on this sketch, or I'm sorry, on the front, I'll sketch and then grab that derive sketch and create an offset on the inside and Again, let's change the units on this part as well. And let's change that offset to it's just maybe 1/8 of an inch, 1/8 inch clearance all the way around. So now I can use that sketch, which is offset from our derived sketch. We'll extrude that, and let's go offset. Let's see, not from that sketch. Blind, we'll say from not blind, we'll say offset from surface. Offset from that one, we'll say it's maybe a full inch. It was clearance at the back of our cabinet. And let's shell this. And let's put a face on that part. So I'm going to continue editing this drawer. I could actually create it as a separate part if I wanted, but let's just, for the time, say we'll create this as a single part, the part that we could then use as our top-down design to then insert into another part and break it into the individual panels. We'll go to the front, sketch, not sketch, I'm sorry, don't go into sketch, just select the front. Come up to our top drawer. In the control, I've got the top drawer face, which is just a little bit larger, as it's already built into I could offset from the drawer itself, but this one's independently controlled because that's some of the variables that I wanted. So I can then say insert, derived sketch, locate this, and orient it. Turn it black. And extrude that as a solid panel in the front. Maybe I only want that 3/4 of an inch. And so on. Let's color these right here while we're this far along. We'll go to the chest of drawers there, and the cabinet, and say a wood, maybe oak. Let's try that one more time. Okay. And the drawer, top drawer, will also set its appearance to wood. And so on. And I can continue doing those kinds of procedures to build the whole cabinet, add the other features on there, like I did with mine, to add all of the other features, add a top panel, and add cuts on it to make it more realistic. And you can see that by doing it this way, I can maintain clearance in there. I could add my rails and rollers and so on, and other features in the cabinet. But it's parametrically defined in such a way that in early stages of design, or in creating multiple variations or a family of parts, I can use this capability to create my models very, very quickly once I've set those up.